Hey Gilbert, I was wondering if you could help me with my math.
Sure. What do you need help with?
Simultaneous equations, they're really tricky.
Sure thing, Norman. Now, when it comes to simultaneous equations, you have to figure out your unknowns. In this equation, y and x are the unknowns.
Oh my god.
From the second equation, we need to rearrange it to make x the subject. We do this by subtracting 4y from both sides.
Very cool, very cool.
Rename this new equation we've created the third equation, and then substitute it for the first equation. And now, you have only one unknown left in the equation, and then we can solve it.
So does that mean we'll get 2 bracket 13 minus 4y close bracket plus 3y equals 11? And then by expanding the bracket, I'll get 26 minus 8y plus 3y, which equals 11, which will result to minus 5y equals negative 15. And then I can easily find y equals negative 15 divided by negative 5, which is equal to 3.
Now that we have the value for y, we can now substitute this to the third equation, and we'll get x equals 13 minus 4 times 3, x equals 13 minus 12, x equals 1. Yay! Now I can do 2 unknown.
That's right!
What if there are 3 unknowns? Beth! Beth! We need help with simultaneous equations!
Sure, what's the problem?
Well, at first, I taught Norman solving 2 unknowns, but now we're stuck on solving 3 unknowns.
I see. Okay, let me give you an example. Here are 3 equations. You have 3 unknowns, which are x, y, and z.
Yup. I remember Gilbert telling me to identify all unknowns and we use substitution.
Yes, substitution is better when solving 2 unknowns, but solving 3 unknowns can be a little bit tricky.
So, what do?
We will solve it by elimination method to create 2 sets of equations with 2 unknowns. So first, we are going to eliminate z.
To eliminate z, we have to compare 2 equations from the sets of equations given. Let's go ahead and compare equation 1 and 2. The reason for me choosing 1 and 2 is because 2z is easily eliminated from another 2z from the second equation. And then the rest of the coefficient of the unknowns can just follow through, such that it will give us a result of 2x plus y plus 0z equals to 495 or 495, and this entire equation will be our new equation that we will compare later on another equation. And let's name this as equation A. Now, let's compare another 2 equations from the 3 equations given. First of all, we have the third equation that we have not used, but it states that there's only one z in that equation. For us to be able to compare equation 3 to the second equation is we will have to multiply the entire equation of 3 by 2 and receive 4x plus 2y plus 2z is equals to 1148. Like what we did on the first and second equation, we will have to compare the third and second equation by putting the third equation on the top and the second equation by below and subtracting the coefficient and the constant itself. And now we will have a result of 3x plus 0y plus 0z is equals to 552. And now we are left with 3x is equals to 552. To solve for x, the only thing we have to do is to divide 3 on both sides, and we will have a result of x is equals to 184. And from then, we can easily solve for y. Now that we have the equation for x, we can easily substitute this value into equation A, such that it will give us 2 open bracket 184 close bracket plus y plus 0z equals to 495. We will have to rearrange the entire equation such that it will give us y as the subject, like y is equal to 495 minus 368. Y will now be a total of 127. Since we have both of the 2 unknowns, we can easily solve z. Let's substitute the value of x and y into the third equation so that we receive a 2 open bracket 184 close bracket plus 127 plus z is equals to 574. And from then, once we rearrange it to such as z as the subject, we will receive z is equals to 574 minus 495. Therefore, z is equals to 79.
Oh my god.
created using Powtoon.